Using applications and slope, y-intercept to write equations and solve that can be tricky. So let's look through this example and work through it together. In 2000, the number of parks in the city was 6. In 2012, there were 14 parks. Let's start with part A. Write an equation to show the number of parks T years after 2000. Now, it's going to be important that they tell us this right here. T years after 2000. That means 2000 is our initial year. This is our starting point. Okay, that's important to notice. So when T is 0, that is the year 2000. If T is 1, that means it's 1 year after 2000. That's 2001. Just kind of, let's just in general talk through that. Okay, so now, since I know in 2000, when T is 0, I have 6 parks. So that leads me to the ordered pair. In year 0, there are 6 parks. In 2012, which is 12 years later, so T is 12, we have 14 parks. So the information they give me allows me to say, okay, I know that after this many years, I have this many parks. I have ordered pairs. If you recall from, I don't know, some point, we know that slope is y2 minus y1 over x2 minus x1, right? It's the change in the y values over the change in the x values, where x's are my years since 2000, and my y values are the number of parks. Okay, so I can solve this. So let's do it. We've got 14 minus 6 over 12 minus 0. So that gives me 8 over 12, which reduces to 2/3. This is my slope. Now, just for fun, that means my city is building 2/3 of a park per year. So because we're talking about in years, every year that passes, 2/3 of a park is created. Great. Now, we also need our y-intercept, and we know the y-intercept is the starting point, right? It's when T equals 0. So we know we have the ordered pair 0, 6, so my y-intercept is 6. So I have the equation, y equals 2/3 x plus 6. Now, that's the traditional one. You'll notice here they say T years. So in this case, T is the same as x. So we could say y equals 2/3 T plus 6. Some people even like to say, well, this is, y could be P. So we could say number of parks is 2/3 times the number of years after 2000 plus 6. All of these mean the same thing, right? Okay, so now let's talk about letter B. And we'll go to a clean screen to do this, but it said, if this pace continued, how many parks would be in the city in the year 2030? Okay, so we know our equation is this. So in the year 2030, well, how many years after 2000 is that? Well, 30, right? It's 30 years later, so we know that T has a value of 30. So I can substitute that into my equation. So P equals 2/3 times 30 plus 6. And now we solve. So to multiply fractions, I can put 30 over 1 to make it a fraction. We can reduce. 3 goes into 3 once. 3 goes into 30 10 times. So this is the same as 2 times 10 plus 6. 2 times 10 is 20. Plus 6 is 26. So in the year 2030, we would expect there to be 26 parks.